Okay, the classic sign, not only is the tension crack, this thing has widened. Sometimes you can get fissures in these cracks that go down quite deep. So you need to really evaluate when you see that differential. Now, you mentioned that you guys, what is it, drag and patch. What do you do aside from that? Doing that on the road doesn't stabilize it. Actually, it only adds more driving force. What do you do to stabilize the roads, this embankments? Nothing.
A lot of times it's beyond our capability
So seriously, how does
as a maintenance officer.
leveling the asphalt?
Why isn't time?
Just keep somebody from hitting it, being run off the road.
Yeah.
Just level. Leveling.
It's an issue of traffic safety, okay? You either close the road or you make the road safe to travel. And the easiest way to make it safe to travel is take the lump out of it. I just put 1,000 tons of asphalt on one slide yesterday.
How much?
1,000 tons.
Okay. How much does asphalt weigh? Asphalt at time.
Excuse me, same with the color feathers.
It's about 145 pounds per cubic foot. Somewhat heavier than soil. Okay, I'm just making suggestions. Remember, this section is called recognition and identification. So you got to be thinking about the processes, what's happening. If I have a slope that's moving and you said you can't afford, you know, on a maintenance budget, you can't afford to fix this, but what is it again? Dragging?
Just put it in. Just put it in operator. Just.
Yeah, no, I know that. I know that. I just
Not drag and patch. Just drag and patch.
drag
There
patch.
you go.
Write that down.
I'll just think NASCAR.
Drag and patch.
Okay, drag patch. I got it. All right. We could seal this crack. I agree with you. You know, road safety is important. You got to level it up. Might even, if this is clay, might even inject a lot of lime or lime flash in that tension crack, because that'll help to strengthen the shearing resistance right in that slide plane. Just another little trick I learned over the years. And then, if you notice, now when you're doing this, like Andy said in Kentucky, they had like 6 or 7 feet of asphalt. And that certainly was one heck of a downward load. What might you be able to do if this is, you know, accessible? Like, do you guys ever, let's say this is only 100 feet or 50 feet long. Could you dig that out with a loader and maybe put some fabric in there to reinforce it? Or dig it out and put some lightweight material in there?
Most of the places that I have a situation like that, it's right along the edge of the river.
Yeah.
The Ohio River.
So it starts at the toe.
It's a lot larger than that.
Yeah, okay. Well, that's, again, you got to know when, you know, you can visualize how big this thing might get.
We have a lot of areas that just move a couple inches a year. And maybe in the spring it'll drop down a couple inches and they level it up, and put another thing to it for another year. And that's how you get these big things.
Yeah. I-65 widening in Kentucky. Going over, this is called the Louisville Drainage Ditch. For some weird reason, the Corps of Engineers had jurisdiction on that. There was the railroad. The only line for Ford Ranger trucks if that line goes out, Ford Rangers don't get delivered to Americans. So they said, no, I can't do anything. The bridge was being expanded. This was the embankment. And you can see they had a bed out here, a bed of improved material. What they did is they dug out shallow clay shale material, and like 30 feet down was black shale, which was very competent, but they never went down there. What they did is they tried to improve the ground, and they put these stone columns in there. And this actually was the top of, as you can see, this is, or you can imagine, this is all shale, Kentucky shale that was put in for the embankment. The bridge abutment is like right in front of this, and it was going to cross the railroad and the drainage channel. And lo and behold, the state geotech folks put instrumentation in here before any tension cracks occurred. I was there actually to teach another course, and the state geo folks said, hey, we have a wall that's moving. They had an abutment wall to support the bridge at the widening. And the instrumentation, the guy said, geez, it's moved, you know, like 1/8 of an inch per day for the last 3 days. And yesterday it moved like 1/4 of an inch, and it looks like things are accelerating on movement. What should I do? And on the back of the napkin, because I didn't have anything else handy, and I was staying at a Holiday Inn, on the back of a napkin, we drew diagrams, and I drew a free body diagram. One of my professors told me in school, a free body diagram will be your best friend. And I always draw diagrams before I do anything. Over 30 years, and it's worked. I like the napkin envelope idea. So I said to Gordon, okay, here's the sketch. I call him Gordon because that was his name, but he's retired, so he's a good guy. He was involved in the project, and he was shot because he was really panicking that this thing looked like it was moving fast. What should I do? I said, Gordon, come in back of the wall about 30 feet, put in some scrapers, which were on the job, and unload this approach embankment. Just where the wall was, leave it alone, and take that stuff that you removed and put it in front of the wall. And he said, well, we're trying to get in touch with the Corps of Engineers. We can't block the channel. And I said, got a big pipe culvert somewhere, or a bunch of them in the district? Well, yeah, but the district engineer won't let us put them in there because the Corps has jurisdiction. I said, Gordon, did you ever hear about do what's right and ask for forgiveness as opposed to asking for permission? The end of the story was the wall moved 10 feet. The cost of retrofit and redesign turned out to be $1.5 million. And guess what? When they took the soil samples for the clay originally, the engineers saw we had strong clay, medium clay, weak, very weak, but it was only a thin layer, and then weak, strong, strong. And in his design, he took the average shear strength. I mention that because it ties into what I said before about back calculations. To assume that soil is uniform is risky. Using good engineering judgment, tying into the geology. Well, guess why this thing moved? Okay, visualize it. It moved towards the river. What's that? Well, first of all, they put on too much material too fast. And when you do that to clay, it tends to build up water pressure. The clay doesn't have a chance to drain. Okay, if there's a lot of water, especially under pressure in a clay soil, does strength go up or down? Way down. 8 feet below the bottom of the embankment was a thin layer. I mean thin. And it was CH material, which is highly plastic clay. And it had a strength of 80 pounds per square foot. For shear strength of soils, that is unbelievably low. Okay? I mean, you would want like 600 as a minimum for that thing to work. Hi, Dan. Want some coffee? No. Okay. All right, so my suggestion to put the scrapers in there, move the material and put it in front of the wall. What would that have done? You're unloading the driving forces, and by putting the same material in front of the wall, what am I doing? What am I adding? I'm adding, yeah, toe resistance.
Balance it.
Okay, so we're trying to balance it. Unload this driving force and put a load in front. That would have saved all this. I don't know, but we never, you can't turn back the clock. It was another lesson learned.
Did that collapse into the ditch?
The bulge that Andy showed came up. It rose in the middle of the drainage channel. This channel is like 40 feet across at the bottom. I would have put those pipe culverts and filled that sucker as much as possible and build a big toe. And, you know, Louisville's kind of flat there anyway. And if water built up, so what? It would still go through the pipe. Okay, concrete pavement, a little vertical separation. Solution. I'm not going to, it's a maintenance thing, and I'm not going to pave it. No drag patch.
That's all they do. Mud jacket.
Who said it? You?
Mud jacket.
Larry gets credit. What else was idea? Larry said mud jack. What kind of mud? Stuff my kid plays in, or?
Mortar-like stuff.
Mortar-like stuff. So you just come here and take an injection pipe and inject under there and jack it up. Now, that's a short-term fix. You still have to find out what's going on to cause that. Okay, something else.
Probably avoid underneath the concrete.
Well, yeah, that's why he's going to pump in grub to patch wood, but the void had to come from somewhere. Okay. Well, there you are. There were tension cracks this way, and then it came around. Well, it turned out that it was part of a slide. You could see the tension cracks on the surface. See that vertical? It actually would have been a circular, okay? It doesn't have to be a perfect circle. If it even has a resemblance of something that is an arc. Now, could it be a straight line and a straight line here? A 90-degree angle? Andy showed a diagram of that before. What do you think? Yes, if it's a sliding block as opposed to a circular arc failure, it would have been. Okay, escarpment in or above the roadway. Now, as I mentioned, the escarpment is this near vertical surface that is exposed. So this, and by the way, Andy mentioned this Tommy Hopkins at University of Kentucky. He had this type ABC, and it was just a nomenclature that he assigned to this. And I thought that this thing was complicated enough, and we wanted to make it simple. So again, don't remove that thing until you analyze it and find out. It looks like somebody had the idea a long time ago that water was a problem here and they got to get some vegetation. And Jim says, don't say plant trees. Why is that, Jim? I'm just curious.
Because that's all we seem to get done anymore is plant trees along all of our roadways. And eventually, we're going to have to cut them down because they're going to shade our pavements and ruin our pavements and make our anti-icing ineffective. We're going to have overtime calls on windstorms.
Thank you, Jim.
Pick them all up.
Hey, where'd they go?
Thank you very much, Jim. Okay.
That's right.
Roots, reinforce. Trees typically, a lot of trees have tap roots that go down quite a bit. Maybe you don't want to plant trees. The solution is don't plant. The solution is plant, but plant the right thing. I imagine, we were talking about Robin Soter. There's a lady by the name of Robin Soter. She does bioengineering. She has all kinds of stuff. She probably has a website. If you look up bioengineering or put in the name Robin Soter, S-O-T-I-R, you can get gobs of information on that. It's called bioengineering, which is a generic term for the type of work she and her company does. And it's basically using the right thing. Robin had showed that you can take what you call live stakes and drive it into the slope, and it would make the slope more stable. Why do you think driving stakes into the slope? These were live plants. It's like putting in a root structure, but you're putting in like pins. And if you pin it back, you're taking this weaker material and you're reinforcing it. So when we recognize what's going on or identify what's going on and really in our own minds evaluate it, I encourage you to not think about the first thing that comes to mind, but perhaps possible alternatives. And you may just come up with a more economical one. As I mentioned, tomorrow we're going to talk about economics and legal liabilities and all, and we'll show mitigation things. But this is recognizing what's going on. Do we have a very clear scarp that we can back calculate this failure? Heather, you seem mesmerized. How many scarps do you see here? A whole bunch. At least one for every finger on your left hand. So, and the shapes are all kinds of things. So that tells me that this side cut in the hill and perhaps some fill on top is very unstable. We have to remember, maintenance ideas are to short term, but man, if you can get a long-term solution for a short-term problem, then that would be good. Look at this one. Multitude of scarps, including way up here. Now, remember what I said about the I-40 slide in Pigeon River. If you walk uphill through the woods, you just might see a few more cracks. So whenever you look at this, you know, don't just say, okay, I know what's going on. Look beyond it, because there may be more geology that's telling you what's happening, and look at, you know, some of the ground features, vegetation, so on. Now, the old dip in the guardrail, you know, if you can't see a dip in the road, usually the old dip in the guardrail tells you that something's happening. Now, obviously, when you look at this and you see a little scarp, you know it's moving. But from the road, if you're just scanning, I assume, like, in your districts, do people routinely, like, drive the roads, especially in the counties? Do they sort of do, like, inspections, just checking things out? Yeah. Okay, what may be visible here is nothing more than a little crack in the road, and if it's so close to the edge of pavement, you might be fooled and think that it's edge of pavement. But the point here by our illustrious colleague was, yeah, drag tags, good stuff.
It's gone.
Hey, don't steal my idea. I might patent this and retire early with Andy. What if we use lightweight aggregate in here for that drag pack?
That doesn't
Lightweight. Lightweight aggregate. Huh? No, lightweight aggregate is material that you manufacture.
very porous material.
Very poor stuff. If it's not highly caustic, slag. Yeah.
As long as it can hold up to traffic, it just crush, like it just crush under load.
Well, it depends. You got strong stuff too. Down in the Delta area in South Alabama, Mississippi, Louisiana, they have a lot of clay and no rock, and they take that stuff and they fire it up and they make gravel out of it, and it's very lightweight. It weighs about 40 pounds a cubic foot. You put some asphalt in there, and you're saying crushing. Well, heck, if you're using asphalt as a cement, it might be. I just came up with that idea.
You're not really putting that much on there at one time, most cases.
Yeah, but well, I mean, it's obvious.
You're putting a couple truckloads across there and smoothing it up. You're not adding that much weight compared to the whole thing that's sliding there. I mean,
Ron, I thought that my idea was great. You're
Okay.
taking the wind out of my sail.
I'll dig it down about 10 feet and take some weight off it then.
Okay, and good point. Thank you, Ron. Andy, put him on the good list there. Yeah, you can put in foam blocks or sawdust. Guess what else you can put in there? What other lightweight materials might you put in? What? Children. No. Susan she's upset with you. Susan, we have to have a talk before you go home. To the girls, your hobby. You could dig it down and put in very lightweight material. They now have foams that they can actually, liquid foam, they shoot it in there, because the foam blocks are something else that people are now using. It just looks like the packing foam for, that come with your TV
Aren't you
set.
creating a catch basin for water? Don't you want to mess up that water valve?
Why?
When you use that foam or?
No, the foam will be actually more impermeable. We're not talking, it's styrofoam. Boats are made from styrofoam. So, under the weight of the road, now that stuff is very strong. And that, we're gonna talk about that tomorrow too. What's that, Jim?
It's also very expensive in that application.
Very expensive in that application, so you gotta use judgment. I don't know, it's just a suggestion. But the key here is, if you don't see a tension crack, but you got a blip in the guardrail. How about a little roller coaster road here? Guardrails that are moving everywhere, a little too late to pass. Dips in grade. More of the same. Oh, that's cute. How many of you guys seriously have seen this kind of thing? Okay, about half the crew. Debris on the roadway. Bulges above, on or below the roadway. Okay, debris on the roadway from an uphill situation means that the slide debris has already traveled that much further. If it's heavily vegetated, you may not see it. But as Andy mentioned, that bulge is kind of a giveaway. So you may only have cracks and not see a scar. But it's just like the slope bulges a bit. It says wet material, so that would be just a little swelling, not necessarily major slide. Now look at the profile. Here's a drainage ditch that you could just eyeball it and see that it probably went that way, and now you've got a bulge, right? And then the slope is relatively smooth up here. Here's another bulge, and of course the fence is a giveaway, and here's a scarp as well. So bulging, this is the Louisville thing. The embankment moved laterally. It slid on that weak, thin layer of clay, and as this embankment moved forward, it squished up all the material that was weak in front of it, and below it, it squeezed it out like toothpaste, because some of the highly plastic clay was mixed in there too. Okay, poor drainage, surface water, culverts blocked, paved ditches broken, we mentioned that. Water ponding above, below, or in the median of the road. Drainage structures. We mentioned the culverts with separations. Drainage structures discharging onto a slope. Classic one at the ends of bridges. You know, people are all worried about the bump at the end of the bridge, so you got a little approach slab, but no one paid much attention to getting drainage off the bridge. Bridges are designed for water to flow sideways or longitudinally. Could be both.
Well,
Yeah, could be both.
how do you go sideways more?
Yeah, it's sideways if you have, you know, the minimum of 2% on a straight road. And if you have some curvature, it'd be super elevate a little more. But it also drains longitudinally at the ends. And when it gets to the end of the bridge, you may have a lot more water and have to get rid of it quickly. And what we recommend is don't put those side chutes right by the end of the bridge, because that's a surefire way of having a lot of erosion and instability. Bring it down a little further and put like a ditch. I got some pictures of that. this is actually, there's a bridge abutment up here, and material had been washing down, and this culvert is being covered up. Yeah. Okay, now we got the old crack in the concrete, but you guys are doing riprap. Now, I mentioned the Hypalon barrier. What about just using regular fabric instead of using the impermeable membrane? We're going to do riprap on all these things. First of all, again, rule of thumb, maintenance thing, if this ditch is pretty steep on the side of the road, how would you modify? You still want to put riprap. How would you modify the riprap? Finer or smaller particles or bigger?
Bigger.
Bigger. Okay? And it would be worthwhile lining the ditch with fabric, because as water flows, even though it's going through the riprap is mainly holding that surface down, holding the fabric down. And the purpose of the fabric is so it doesn't suck the soil below it out. So just like as air goes over the top of the chimney, the smoke gets sucked out, this is the same concept. As water flows over the ground, okay, have that filter fabric, because there's actually suction pressure that will suck soil right through the riprap, and you don't want to have a little instability right in the ditch. So if you put a filter fabric under there, that's good. Just another rule of thumb, a good tip. How many of you folks in the maintenance yards have rolls of filter fabric? Larry, Doug? Well, materials.
No big bunch.
Okay, and what, do you use it for this kind of application? Yeah. And French drains here and there? If you got a crack in the road and water is coming up in the roadway, you can also just make a French drain across the road, intercept the water, and that sort of thing. But if you ever put in a pipe and put gravel around it, line it with filter fabric. Here's the tip. Some people pay big bucks for this tip. Federal Highway has a geotextile engineering manual, and it talks about using the right type of fabric. There are literally hundreds of manufacturers on fabric, and what you need is to select the right grade, and you don't want the fabric to clog. Somebody said, maybe it was Kurt, about the iron type material clogging the fabric. Well, as soil, you want the soil to pass through the fabric, but very slow, very little. How do you know if your fabric will work as a good filter? Mason jar, scoop up some soil, push your fabric down the top of the mason jar, run water into the jar, and if that soil disappears and the water becomes muddy looking and the fabric isn't clogged, you got the right fabric. So you don't have to do all this high pollutant stuff when you're using it as a maintenance product. But if you see those pipes with the sock around it, don't use that, because that fabric might be, it has a good chance of being the wrong material. And those things might clog up, they're very thin. So we rather just, cut off a piece. You can test to see if it'll clog. And if it doesn't, then use that. Okay, this looks familiar. Okay, here's a side catch at the side of the road, concrete line ditch, totally ineffective. This is kind of classical. Big sinkhole underneath. The concrete's passing through the air. Same thing, water flows right under this baby. Why would that tree grow in there? Is concrete strong or weak? I heard 1 week.
Depends on its compression or tension.
Alex says it depends if it's compression or tension. Who said weak? That could be the bonus question today. Harold, good man.
It's a lot weaker than that tree if it takes time. Time, that tree will move it all.
Yeah.
Duck it all.
If you pull concrete apart, it's very weak in tension. That's why we put steel in concrete. So temperature steel, or slab on grade stuff, you put in welded wire fabric. Would that stop cracks on a continuous pour line ditch? No, it doesn't. So you guys have the right idea. Is that actually the riprap fabric thing? Is that in the state standards? That should be in the state standards. Okay, that's another tip. Okay.
Water in the
Yeah, standing water, wiggly guardrail, crazy pipes in the wrong place. What's going to happen? What if they dip that down steeper and let it flow at a steeper grade? Would that be okay?
Drop box.
Huh?
Increase
Drop box.
There's things fall apart and go down the hill too.
Okay, as you steepen up the pipe, you increase tensile forces, and you might tend to pull the joints away. So this solution is not a good one unless the slope is very well protected, which you could put in fabric and riprap there, and that might work very well. Okay, here's an outlet, there's the riprap, but I still see erosion on the sides.
It's a drivable head wall.
Okay, here's another unlined ditch, and water's coming off the road. Oh, that's that same motel. Son of a gun.
Different angle.
Different angle.
The old motel.
86, that's like. Poor drainage, subsurface water, springs on slopes or at the toe of the slope. And if the soil is poorly drained, but springs come out, it's usually flowing through what? A crack, a fissure in the soil, a joint in materials, but water will flow. Light and dark areas on the slope. If you tend to see a dark area, that would tend to say water is coming through or not.
Water, yeah.
Water, sure. If you put water on it, it darkens the area. Soft, muddy areas on the slopes. Vegetation, cattails, green grass, and dry season. Okay? If you got poor drainage because of gravity, in those side ditches, we might have to put in a French drain and drain it by gravity. Little water on the side slopes. Cattails. I've never seen cattails on a side slope though.
Oh, yeah. Oh, yeah.
Who said they have? Yeah? Did you guys say bull?
Well, yeah, I said,
Oh, okay. Oh. Erosion, toe of the embankment, toe of a cut slope, or on slopes embankment. Gene Geiger gave us a list of the 4 most common problems in Ohio. And he said toe erosion was one of the biggies. So make sure you pay attention to features that would mitigate the erosion. Okay, so you're going to need weight and filtration. Best thing is a filter fabric and riprap. There's the old little dip in the, this is the end of the wing wall, and if you look at the side wing wall, you can see that the soil was way up there at one time. And it's obviously moved down, and this is, the water should be brought further down the road. You might have to drag patch there and level it off and put in a little curb. I'm gonna be an expert. You guys have really taught me well. Okay, they put riprap. Is that still a good thing right by the bridge abutment? I don't like it personally. I want to move that stuff off the approach. Changes in features. Oh, trees, tilting telephone poles, and fences out of alignment. Crooked tree with a bend in it. A straight tree. And it says if you have a straight tree, it's a recent failure, but if you have a crooked tree, it's older.
Yep.
Tom, why is that, do you think?
Time is going to go to the sun, going to straighten itself up.
Okay, trees want to go straight up. So if you have a bend in it, it says that this slope has been moving over time because the tree is constantly trying to go vertical. If it's straight, it means it hasn't had time to go vertical, so this is more of a recent failure. And frankly, this is more of concern. These things, you can see what's going on and hopefully do a quick fix. If you got those bent trees and it's not just a bulge and a shallow slide, you got to think, use that as a tip, that this is a bigger problem than a little area. Especially if you look at the size of the tree, you can estimate the age. Okay, that's a fairly young tree, but it's got a bend in the base. I also see a tension crack in the ground here. There's another tension crack, a scar. So we want to look at the signs that are on the ground. Okay? The old telephone pole. Ooh, that's a good one. Now, why aren't those telephone poles curved? That was a joke.
You can get the guide wires on. There you go. That's exactly.
I get more punchy towards the end of the day. Okay. We're gonna let you guys go soon, so I'll just close out this section. And then, should I give you the exam as a take-home, or you want to do it in the morning?
We're gonna do it in the room.
Okay, I got a mixture of opinion here. Okay, changes in the structures. Okay, changes in structures. Bridges, you might see tilting abutments. I mentioned this before, abutments moving towards deck beams. So that means the end slopes have moved in and the bridge is tending to buckle. Settlement of approach slab could be erosion or it could be soil settlement. In the embankment itself, you want to look at the side slopes and see what's going on. Retaining walls overturning, it might be tilting over, or cracks in a wall. And foundation cracks, masonry is very vulnerable. Concrete masonry is weak in tension. Okay? This is an indication that this abutment has rotated back, correct? So there might be a slide right in back there. And here's another sign. Notice the rocker bearing is not dead center. It's moved. The top is moved back a bit. The girder is right up against the back wall. Expansion joints are closed, partially open. Partially open. This is a lot of corrosion.
Yeah, buddy.
Yeah, probably de-icing salts, huh?
Salt dry.
Here we go.
Guess what? If you
We got a bonded situation here.
if you add salt to certain soils, it could weaken the strength of the soils. Just another tip. Because especially on clay soils, because it changes the positive and negative charges. Now you're putting in sodium ions, sodium chloride.
You can't worry about that, buddy, when you're going to be second to none in small base.
Okay. I don't see any drainage here coming off the bridge. Tilting wall. Little tilt in this wall, huh? Oh. This is, I've seen this place. That, yeah. And the trees are growing inside the garage. This was the one, where's Andy? Do we have the slide in here? This is the one that the crack went right through the lady's house? And then they filled the backyard, remember that? No. Okay. Ah. Now, would you consider this a mobile home? And move from up there. Could be. Whoa.
Slight tilt.
Yeah, a little tilt here, going down. Whoa.
Tilt. It's lost a wing.
Okay, I've seen this rarely. These are steel piles that have been capped in groups. This is not done much anymore. They used to cap a few piles and they would just set the girders on there. Now I would design it as one continuous girder or grade beam over the top of the piles and make sure it's well reinforced. But the story here is it moved laterally. It could be a shallow or deep slide. Mud jacking, yes. You know, here's a tension.
Nice bridge.
Tension crack, a new meaning to tilting.
That's a new design.
Drag patch it
Okay,
On beads.
these are tilting abutments and bridges. Cracking up here. Sometimes you don't see this tilting, but you do see the joints being closed. That's a sign.
We never have
I'll tell you a quick funny story. The Obion River flows into the Mississippi. Mississippi dropped 33 feet. The side slope moved on both ends. 10-span bridge had never opened. And they started to see cracks on the top, transverse cracks. Started to see cracks around the side slope. Of course, I knew right away from my own experience that when the water drops quickly, rapid drawdown, the soil becomes twice as heavy and you're more likely going to have weaker resistance along the shear plane, but increased driving forces. And what happened there, swear to God, this is a true story. I'm not going to tell you who said it, but they actually said, how about tying come-alongs to cable and let's pull the bridge back. And I don't know if I put a picture in there, but I don't think they've got one suitable. And usually when you see that kind of tilting, it's a much bigger problem. And what we found out on Obion River, 50 concrete displacement piles in a cap. And the movement of the earth was so powerful, it sheared the piles. I didn't believe it until I saw it. Because a reinforced pile, concrete pile, it takes quite a bit to crack those things. Because it literally sheared up the piles. Examine adjacent developments or drag patch, there you go.
underneath.
Yeah.
Hell yeah.
This could have been, we've seen a few things like this where they've had mining of gypsum and other materials.
Wait for the ore underneath the road.
Yeah, it looks like coal.
There we go.
Yeah.
That's George Nicholas' office right there.
Instrumentation. Okay, when the embankments, the side slopes get wet, they get heavier. A piezometer is a device that measures pressure in the water. So if you get it down into the weak clay material and you see increased water pressure, you got to wait for that water pressure to dissipate before you load up that soil again. So piezometers are a good way of monitoring the pressure. They're installed just like a water well would be installed. And then you take electronic readings. Slope inclinometers, this is just like you install a pipe. It's the same thing as having a tree on the side slope. But when you drop a pipe and there's some slope movement, the pipe does two things. They run a little torpedo down the tube, and it's, you know, it takes readings electronically, and there's a tilt meter in there, and it'll tell you if that thing is tilted or moved, and that helps you to see where the slide plane is. If you have a slide that's been going on for a long time, it helps you identify the slide plane. And these are all electronic cables. I'm certainly not suggesting that this be used on a maintenance thing, but these are just simple ways. Frankly, I like this a heck of a lot better because it's cheap and easy. Just put a couple of lines of stakes and you're more likely going to see it move just like the guardrail. Slope inclinometer, like I say, if you see the little torpedo reading, this tells us here's the failure surface. So if you want to put in a couple of inclinometers, even before, you may only see a tension crack, but if you see other signs on the slope, it may tell you this could be a bigger one, and since it's been moving and drag patch put on the top for years, and maybe it's time to do a further analysis. Soil rock identification. Andy talked about liquid and plastic limit. Just to repeat something that Andy said, this is kind of a simple way to remember. The liquid limit is the maximum amount of water a soil can hold before it turns liquid. So it's the limit of water before it liquefies. The plastic limit is the limit of moisture before, while it's still plastic, but before it becomes solid. And, you know, the experienced person can pick this stuff up and just run it through your hands, make a little 1/8 inch roll, bite it between your teeth. You can tell a lot about it. Don't swallow when you try it. Natural moisture content is kind of an oxymoron. Whatever the water content is in the soil could be considered natural, but is that necessarily natural? Just the moisture content is the only thing that's relative. But the old books used to say natural. That's just a little trivia. Some soils weigh more than others. What's heavier, a clay or rock?
Depends on the rock.
Depends on the rock. What if it's a solid piece of rock?
Very heavy.
It's heavier. The specific gravity of the rock might be like 2.5. The specific gravity of the clay might be the same, but the clay's got more voids. It's lighter. So weight